So again, if you want to follow along with the slides, it's slides.lukeb.co.uk/frontendne 2018 Bluetooth. Simple name because obvious. Content warnings for this one, animations, content warnings will appear down there again. So who has a Bluetooth device with them right now? Hands up. Everyone. Yeah. So Bluetooth's super popular. You use it to connect to all sorts of devices. Over 3.6 billion Bluetooth-equipped devices are shipped every year, which is a lot. Bluetooth, the spec was first published in 1999. It's currently on version 5, and that was published in 2016. It's frequently used in smart devices because that's a sort of nice way to communicate. So stuff like smartwatches, like that, or that, same thing. So like Android Wear, WatchOS, there are some other things like that. Smart door locks, so that's the August smart door lock. There are other brands, including like Yale, so your traditional door lock manufacturers, and then smart forks. Yes, they are a thing. This one raised just under $135,000 on Kickstarter, and they delivered, which is rare for a hardware project on Kickstarter. But these all need their own apps. They take up space, and you've got them installed even if you're not using the app often or the device often. And it leads to this. So what if we could use the web instead? The web's a massively powerful platform. Let's see if we can use it. Web Bluetooth. So that's Bluetooth in the browser. It's really cool. On user input, it fires a connect. It pops up a device selector. That device selector. You select it. It's a native one, so it's not implemented by the user. And you connect to the device and it's available. It only works over HTTPS, so you've got that added layer of people can't intercept your code and mess with people's devices. And this means we can build PWAs to give a great experience so that you can have an offline application that's really lightweight and just uses the browser. So browser support for Web Bluetooth is all right. So it's in Chrome on Windows, Mac, Linux, and Android. It's in Samsung browser, and it's in Opera. Edge and Firefox are considering, and no idea about Safari. They're always very secretive. Maybe, we can hope. Firefox is, Mozilla are quite involved in creating the spec, so that's a strong indication that they're going to sort of put it in. It's in their experimental browser Servo, or experimental browser engine Servo. So Web Bluetooth uses Bluetooth Low Energy, also called BLE. It was introduced in version 4. It's different to traditional Bluetooth in that it has a lower data transfer rate, so it's not good for audio streaming. But it's also got a lower power consumption, which means that it's great for constantly on devices. It sleeps when it's not active. And I'm going to go through a few core concepts. I'm going to cover the minimum because the Bluetooth spec is 2,822 pages long, and I'm sure none of you want to be bored by that. I didn't read the spec either. So first is GAP. GAP defines how devices connect to each other. So Bluetooth has the concept of central and peripheral. So central is usually something like a phone or a laptop, and peripheral is stuff like forks, watches, heart rate monitors, stuff like that. And then central devices can connect to many peripherals, and peripherals can only connect to one central device. Sorry, I just realized that my hotspot's on, and I've taken my jumper off because you lot would get distracted by it. So peripherals can only connect to one central device. The theoretical connection limit is over 2 billion. Oh, okay. Which is a lot of forks. But different platforms have different actual limits because they define what they feel is sensible, because you're not going to take it to the extreme of having 2 billion devices connected to your phone. If you do, I'm worried. And then we have GATT. GATT is how we define... GATT defines how data is transferred between devices. So with GATT, there are 2 roles, server and client. The server holds all the data related to a device, and the client can query the server for that data. So this is sort of switched around. So the fork is where we want to get the data from, because we want the information about the fork. And then the phone is where we want to get that data. And then data on the GATT server is held in a few different levels. So we've got profiles, services, characteristics, and it's sort of a nested key value store. So profile is the first one, and it doesn't actually exist on a device. It's more of a specification grouping for one or more services. So you can have a standardized one or a bespoke one. So there's standardized ones for heart rate monitors. Or the fork will have a bespoke one, because if they've standardized a fork one, I'm kind of worried. And then we have services. So a service is a group of related characteristics. It's identified by a UUID, and again, it can be standardized or bespoke. So the heart rate profile has the heart rate service and the device information services. And then the fork will again have bespoke services. And then we have characteristics. A characteristic is a single data item identified by a UUID again. Again, it can be standardized or bespoke. The default length is 20 bytes, but systems have ways of using longer lengths. And then there are a few different properties that can be set on a characteristic. You can set one or more of them, and these define what operations can be performed on a characteristic. So we've got the read permission, which means that the client can read the characteristic. Nice and simple. And then the write one, which means that it can be written to. And then the notify one, which means that the client can subscribe to updates about that characteristic. And the update will be pushed from the server as the value changes. And then indicate, which is similar to notify, just the server expects you to confirm that you've received that data. So let's make some traffic lights. Let's have some practical examples. It's kind of dry otherwise. So a simple button of me pressing a button, and it turns it on and off. Connected by Bluetooth. So I have one characteristic for this. It's called on-off, because I'm terrible at naming things. And that's how we define the state of the traffic lights, whether they're on or off. I guess it should be stop-go. And we can read or write to it, and it expects a 0 or 1 written to it. We have to do this, we have to connect. So we have to have a button press or some sort of user interaction to be able to do this. And then it'll fire. We have the native device selector. You select your device, and then we can do that. So we filter based on a specific service UUID. You can filter on different things, but this means that you get less devices that aren't relevant. This will only show devices that have this service available. And then we get, out the end of this, we get the device object. And then we have to connect to the GATT server on the device. We then drill down using the service UUID that we've got to get the characteristics from that service using another UUID. And then we can have a cached instance of the characteristic that we can call methods on. So we can write to it, we can read from it. And we want to get the current state to begin with. So we read the characteristic, we get an array buffer. We've got to convert the array buffer to a string. We pass the integer, and then we cast it to a boolean so that we've got a true or false, so we know what the current state of the light is. And then if we want to write to it, to update the state, we work out the new state, write the state to the characteristic as an array buffer, and then update it by sending update our current state in the application. And all of this is JavaScript. There's JavaScript on the server sides. It was kind of besides the point, but if you want to see what it is, it's all at that URL. These slides will be out on Twitter later, so if you want to get it, you can go and have a look there. It uses a library called Blino, and then a library for the LED control, and I just glue it all together with a bit of logic for how it should turn the lights on and off. But wouldn't it be cool if we can control each light? It's kind of traffic lights. We don't need traffic lights in our home, unless your house is really busy. So a color picker, set it to reds. That was supposed to change to blue, but apparently not. Okay. So we have two characteristics here. We have one called pixels. It's reads only, and it has an integer of how many LEDs there are. This is provided by the server, and then, or by the node instance. Yeah, server. I was right. The second is a write only characteristic, where we can set the color of an LED with a JSON object. So the connection's done the same. There's no point in me going over it again. The characteristics, we have to get both of them so that we can cache them and deal stuff with them. We use them in slightly different ways. So if we want to read the number of LEDs, it's similar to what we did to get the state before, and then we just pass it to build the drop-down box in the UI. And then to write the color to the LED, we have two bits of linked information: the position, so which of the three LEDs it is, and the color of it. It doesn't make sense to split it into two characteristics because you have to do two separate writes. So it's in a JSON object, it's written to one characteristic, and then it can get pulled out at the other end and dealt with. And again, it's all JavaScript. It's a node service. It's a Raspberry Pi. Again, Blino for Bluetooth, and a library for the LEDs. And then let's do some drawing. So this is my favorite one. That's connected by Bluetooth, and that's updating in real time, and it's amazing. So that's I was going to bring this, but I tested it last night, and Bluetooth doesn't work on it anymore, which is kind of a core component of it. I don't know what's up with it. I was devastated when I found out it wouldn't work. That's why I brought the jumper with me, because I needed something interactive. So that's a 16 by 16 grid that I had to solder by hand. Well, not solder by hand, but I soldered the strips together, and I'm terrible at soldering. So we have two characteristics. One is read-only, returns the number of LEDs, or the dimensions of the grid. And then the other is a write-only, where we can set a color of an LED with a JSON object. Again, we connect the same way. We want to grab both characteristics again. We read their dimensions. This comes as a JSON blob to tell us the X and Y. And then we can pass this so the editor can put it into a representation that we can work with. And then we write to it. We have our X, Y, and the color, and we just write which LED we've selected, or which coordinate on the grid we've selected, and then what color we want it to be. And then send that. But it couldn't keep up when I was drawing lines. It would just have every so often a gap in it. It was really slow. And this is because every time you write a characteristic, it responds. And this means that because the client is the client is waiting for that response, it'll go, I'm waiting before you try and write. And if you try and write whilst it's waiting, it'll go, no, I'm waiting. And it will just reject your call. So anything that you think you've sent doesn't actually get sent, and you just end up with gaps. But there's a write without response property. So we can use that and we can just keep throwing data at it and we don't care about a response. And we'll know by looking at it if the display is wrong. So it's fine. But it cuts the amount of data that we can actually send. Because the way a lot of the systems worked is when it got a response back, it went, okay, cool, I've got some data back from you now. Let me send the next chunk. And it worked out that it has to time together. So I had to cut it down. I mentioned that it's 20 bytes, but yeah, as I said, it glues it together. If the server doesn't respond, the client doesn't know to send the rest. So the JSON blob is 33 bytes, which is more than the 20 bytes. And I knew that I wasn't going to have any commas in my actual data, so I just comma separated it, and that's 10 bytes. I even took off the hash because the server knows that it's getting a color there. And then, yeah, I took it into work whilst I was building it, and everyone was saying, well, how do I get rid of it? I was just like, oh, just use black and go over everything again. It takes ages because you miss ones and you have to find it. And so the most requested feature was a clear button. It made sense as a separate characteristic because I'm not going to write to every single one, say, make this black, because that's 256 calls, and no. So it writes a string of clear, and it'll clear them. I don't know why I made it a string of clear. I just felt like it. And all the JavaScript for this, again, is here. It's up on GitHub. And then, yeah, so if you want to learn some more about Bluetooth, or BLE, Bluetooth Low Energy, here are some resources. So Adafruit has a really, really great introduction to Bluetooth Low Energy. It has a lot of these concepts. Blino, I've mentioned it a couple of times. It lets you write Bluetooth peripherals in Node, so you can just control it. And then the bottom one lets you control LEDs, control RGB LEDs like NeoPixels on a Raspberry Pi from Node, which is my use case, and it's great. Some guy took the Arduino library and completely ported it into Node, which is amazing. So yeah, thank you. That's everything on that.